Hi, in this video we'll talk about permissioned blockchains. We will discuss how they differ from public blockchains, how they work, and how you can best prepare for implementing them in your project. If you are already familiar with this technology, I will also show you how it can be applied outside the typical use cases like supply chain or corporate networks. For example, in cross-border payments or digital identity. I'm Dominik Zyskowski, Consulting Director at Espeo Software. Over the past 8 years, I have led many public and private blockchain implementations. We have worked with companies on every single continent, including many enterprises listed on the S&P 500. I helped Espeo Software become a Hyperledger certified service provider and a founding member of the Linux Foundation's Decentralized Trust. Together with my team, we have delivered over 30 presentations on blockchain applications in finance and other sectors for some of the most important leaders in the world. While public blockchains like Bitcoin or Ethereum often take the spotlight, permissioned blockchains present unique opportunities for industries that prioritize privacy, security, and accountability, such as B2B. Today, I'll be reacting to a recent talk by Agnieszka, our senior solutions consultant, on permissioned blockchains. She has done an incredible job explaining this subject in clear, simple terms. So I decided to pick the most interesting snippets and watch it together to provide some extra context.
Public blockchain is the one when everyone can send a transaction. So it's open to write in. And a private blockchain is the one that, well, only those who participate, who are vetted, can send a transaction. On the other axis, we have permissioned and permissionless, which is about if we know the people that are acting, or if they are anonymous. And most of the public blockchains will be permissionless, and most of the private blockchain will be permissionless.
A permissioned blockchain differs from public or permissionless blockchains because only verified parties may join the network. Participants can have different levels of permission or data access rights. There are a few other differences between permissioned and public blockchains. For example, public chains usually rely on proof of work or proof of stake, which open validation to anyone but incur high latency and resource cost. Permissioned chains, on the other hand, often use practical Byzantine fault-tolerant or Raft-style protocols, putting the transaction on the ledger in seconds with far lower energy use. There are more major differences, and I will be sharing more about them throughout this video, so stay tuned.
Some permissioned networks have some special features. For example, if we have like 80 nodes in Hyperledger Fabric, we might all of them, and
that's a huge number actually.
But we decide that some kind of information should be put only on the nodes of legal firms. There's 4 of them. We can actually put it into the blockchain, so this information is still permanently stored, but only on those 4 out of all 80.
As Aga mentioned, in permissioned networks, we can isolate the data. This means you, as an administrator, can control who can see or change each group independently. In Hyperledger Fabric, we use a feature called channels to restrict access to transaction histories for unwanted parties. Only authorized nodes, such as the 4 legal firms, can see this specific channel's data.
Being said, there are enterprise-grade blockchains. Those blockchains are very specific because they are to be used in businesses, often in complex businesses, with a lot of procedures, regulations,
in complex B2B processes usually.
All of these mumbo jumbos. And those blockchains are typically prepared for that. Yeah, they need to adapt. The company needs to be prepared to introduce the blockchain into its processes, but also the blockchain is ready to be, is ready to implement some kind of this corporate policies. And this kind of enterprise-graded blockchains are for mature projects.
I'll give you an example of how this is done in Hyperledger Fabric. There we can manage network rules with policies. These policies live in the channel configuration. Let me give you 2 examples of policy types: the signature policy and the implicit meta policy. Signature policy lets you build complex approval rules. You can combine AND, OR, and other fresh-code rules like N out of M. For example, you might require approval from 2 administrators from the finance department and 3 members of the board. Or you could ask for 6 out of 11 managers from the entire company to sign off. Signature policy gives you that flexibility, which is often needed in corporate scenarios. Implicit meta policy is simpler and sits on top of other policies. With it, you can set up simple rules such as that the majority of corporate branches have signed off on the document.
And here comes the Hyperledger Fabric, which is probably the most popular blockchain, enterprise-graded blockchain. It's a private
it is the
blockchain,
most popular one.
blockchain. It's a go-to solution because one of a few things. First, it's old. Yeah, it's already
I would say
been
it's
broken
mature.
sometimes. It's used by banks and global corporations, and let's say that nowadays Linux Foundation will say that, well, okay, there was this feature, but well, it won't be anymore. Yeah, like we know that we have some significant players there, and we need to take care of them. And it's part of the Linux Foundation, which is a quite reliable brand. From the technical point of view, it's very adjustable. There are multiple consensus that can be added. So depending on what kind of consensus is preferred by the project, then we can implement.
Fabric has
It
pluggable
goes also
consensus mechanism.
with the chain code.
Here at Espeo Software, we implement Fabric chain code in Golang, JavaScript, and Java. Each language has its own SDK, so developers can stay in familiar territory. In a microservices architecture, you can choose the best language for each service on integration point, whether that's a performance-critical Go module, a Node.js API layer, or a Java-based enterprise backend.
Was the decentralized crowd lending platform that we built, and on this platform, we get some things covered by the blockchain. Yeah?
Here Aga mentions our Monofilo project, a decentralized crowd lending platform. It needed a blockchain because Monofilo connects lenders and borrowers directly. Once a loan agreement is recorded, it cannot be altered or deleted. With blockchain, we automated verification through smart contracts and significantly reduced paperwork, overhead, and fees. We used a permissioned blockchain, Hyperledger Fabric, because of sensitive borrower information and payment schedules, which we isolated and in private channels, so only authorized nodes see them. As you can probably guess, we also needed an advanced consensus mechanism and multiple chain codes to manage the system's functions.
JP Morgan created Kinexis because, well, they knew that payments, especially international payments, are long and costly. If there is
This
any
is true.
scam or if there is any error or mistake, sorting it out is just nightmare. And as long as it's nightmare and a lot of manual work, it's very, very expensive. So even worse situation.
And time consuming.
Finally, exchange rates change constantly. So if during the transaction money is exchanged 2 or 3 times, then well, whatever was sent and whatever was received, adding the fees of all the participants, no, that doesn't matter at all. And there are more and more international transfers because companies gather new markets, want to get representation somewhere, people travel. There are also more and more companies trying to make it easy and cheap, so people are more willing to use this kind of transaction. And with all of that, what JP Morgan did, they built a distributed ledger.
We covered this topic on a previous episode of On the Block. In our Swiss-related segment, we explained why cross-border payments are such a challenge and how blockchain technology could address them. Here's a fragment from that video.
Here is the most important point. Rather than being threatened by distributed ledger technology, Swift is finding ways to use it by making its services faster, more transparent, and even more reliable. For example, DLT can help settle payments almost instantly, cutting out delays caused by banks or other intermediaries. This could make Swift's current system for international payments, called Global Payments Innovation, even better. DLT also shines when it comes to transparency and security.
Transactions recorded on a shared ledger can be tracked in real time, and fraud or errors can be spotted more easily. Swift could also use DLT to embed checks for compliance, such as automatic screenings for fraud or sanctions. This would make transactions faster while still meeting global compliance rules. If you want to watch the whole video, you can click on the link in the top right corner.
Yes, blockchain requires infrastructure. It can be very different depending on the project, but one thing is for sure. nodes need to talk to each other. They need to synchronize. So we cannot decide that the blockchain node would be put in a very, very secure and unattainable from outside place in our infrastructure, because they need to connect to another nodes, and that's just the way. And you may think that it's obvious. I've been in a project where it wasn't. So yeah, it happens. It's good to think about the infrastructure because even though, yeah, it will work with anything, it's good to plan it ahead.
It's worth noting that every blockchain layer carries costs. With public networks, you avoid running your own nodes, but pay high gas fees per transaction. Private chains waive transaction fees, yet demand investment in infrastructure, servers, and ongoing maintenance. You can outsource that with a cloud-managed service like AWS Managed Blockchain, but you'll still incur charges.
Another one, append-only issues. I don't know if there's any way to avoid it. Like, we all understand that the blockchain is the add-only ledger. Yeah, we store the information there that permanently. Of course, that doesn't mean that we cannot update the information or we cannot mark the information as no longer valid yet. But the information that was put there stays there, and it's put there with the metadata, like real metadata. So when someone comes to us and says that, well, they need to add 2 more features for the yesterday transaction, or they need, that was great, but with yesterday date, we need a few more information stored.
Blockchain is immutable, basically. It's not possible.
It's all
True.
about, well, the blockchain is about this immutability.
There's one more important consideration: data privacy laws. Regulations such as GDPR and the right to be forgotten are at odds with blockchain's immutability. Fortunately, you can address this by storing only data hashes on-chain and keeping the actual records off-chain in a standard database. This pattern, known as private data, is a built-in feature of Hyperledger Fabric. Hey, if you are enjoying this video and would like to discuss how to best leverage permissioned blockchains in your scenario, please reach out to me directly via the form below or hit me up on LinkedIn, and we can discuss how to best approach your project. The discovery meeting is free, so don't hesitate to reach out even if your project is in its early concept stages. Back to the video.
When we start blockchain project, it's often that we need as many nodes as possible. Companies
Sometimes less is better.
Of other stakeholders to become a node, to become a validator. And project gets stuck at this early stage because not everyone is ready from the infrastructural point of view, not everyone is ready from the technical point of view.
That's a very usual situation.
Don't trust this technology or anything.
That's a real life of projects.
So many time on trying to bring everyone on board that we forgot about the business use, the business case. Because if everyone is on board with this new process, with this new app, with this new way of doing things, we don't have to have them as nodes. Just, well, 2 nodes is enough, yeah? It's still a network, and it's a great start. It's definitely better to start with 2 nodes, and everyone who will be using the app then start with so many nodes after 2 years when no one wants to use it. So
it's generally best to use an uneven number of nodes in a blockchain network. The exact requirement depends on the consensus mechanism, but a practical guideline for a private network is to run at least 3 nodes. This ensures that if a node shuts down or behaves maliciously, the network can still reach consensus and continue operating correctly. So I think it's enough for today. Thanks for watching, and remember to stay on the block to stay ahead.